All right. Avery, you and Sergio are in total control, sir. Take us away.
Perfect. Can you guys see the screen okay
I
with
can.
our
Yep.
first patient? Okay, perfect.
Yep.
Well, we'll go ahead and get started. First, I wanted to thank you and your whole team for kind of putting all of this together. I'm sure everyone knows in the industry, this is kind of a busy time of the year usually where everyone's going to trade shows and we're all getting together in the industry. So with everything going on in the world right now, it's really great that we're still able to kind of do this over technology. So thanks for getting everyone together and getting the whole industry kind of lined up and giving us the opportunity to kind of stay connected through all of this. My name is Avery Hodge. I'm the sales coordinator here at the Matrix Wand. Joining us today on our webinar is Sergio Correa. He is our Director of Training and Technical Support here at the Matrix Wand as well. And today what we wanted to do, we're going to do a few of these series with Kristen over the next few weeks. And this first one, we kind of wanted to focus on a few hot topics in the industry right now, some newer things that are kind of plaguing our shops, things that we see when we go in and out of the shops that are kind of bottlenecking and causing issues. And those are, of course, we all know ADAS and suspension. This isn't necessarily new. I mean, ADAS has kind of been in vehicles all the way since the early 2000s, since 2003, 2004, when we really started seeing some of these passive systems come in. And we've never really had a great way to repair them. No one's really been sure, and it's become an increasingly big problem in our industry and in our shop. And we all know how much of a heartache suspension can be, especially when we're waiting to the end of the repair to address some of those issues. So the problem, kind of what we just outlaid, is the manufacturers are flooding the market right now with these advanced driver assist technologies. And it really starts with the structure and the suspension of the vehicle. If we try to go and address any of these issues during a repair without first checking and verifying that the structure and our suspension is where it needs to be, we're chasing our own tail. And when we do go to repair these systems, all of the repair procedures are currently based on undamaged vehicles that have never been in an accident before. And when we go to repair them to the OE spec, it's time consuming. We're using a lot of strings, lasers, plumb bobs. We need a lot of space. It's just not very practical to do this in the body shop. And it's resulting in a lot of increased cycle time and additional costs onto the repair. I know I'm preaching to the choir when I talk about that dance that we all play when we send a car to the alignment shop or to a dealer for a recalibration. When we talk to companies like Aztec, 50% of their failed calibrations are due to unidentified and unrepaired structural damages that are still existing on the vehicle when it's sent off for the calibration at the end of the repair. That means if we didn't have that fail-safe of the calibration at the end, we'd be sending out these vehicles that still have additional damages and could be potentially unsafe for the driver of the vehicle. And, our industry and our shop, we're kind of in a hard spot. A lot of this equipment is extraordinarily expensive to purchase, and not all of it does everything you need to do. There's not a catch-all piece of equipment that can do everything that you need. And a lot of times it's extraordinarily time-consuming to set up, like we know. And historically, the best thing that we measure as a collision industry is the underbody. We haven't really done a good job as an industry applying what we do to the underbody of the vehicle when it comes to measuring to the upper structure of the vehicle. And when it comes to ADAS and the functionality of a lot of these ADAS sensors, that's critical. That's absolutely critical. So that's really what we want to focus on today through the presentation. So like we're talking about, we've seen this increase in ADAS, and more importantly, as a result of that, we've had an increase in the reliance that we have on these systems as a day-to-day driver. We were just up at the Verifax Symposium not too long ago in February, and they were talking about, one of the speakers was talking about how he's teaching his son to drive. His son turned 15, they went and got his permit. They're teaching him to drive on Daddy's F250 with all the fancy sensors, the pre-collision warning, the blind spot monitors, the radar cruise control. So he learns to drive over that year. He goes and gets his license when he turns 16. They buy him an older 2005 F-150. And within 10 days of him driving this truck around town, he crashes it, unfortunately, by merging into someone in the lane next to him. He had become so self-reliant on that sensor, he wasn't even checking over his shoulder anymore to see if anyone was in that lane. So when we go to fix these systems as a collision repair professional, we need to keep that in mind. We need to make sure that we understand that people are relying on these sensors more than they should, whether it's right or wrong. They are, and we could potentially be putting them in a dangerous position if we don't approach it the right way. And all of these sensors are intertwined. They all work together. Sometimes multiple sensors will work as a system to perform one functional system, one functionality, like your blind spot monitor. Maybe it's using a camera and some kind of radar or LiDAR to perform that task. So when we mess with one system or we're repairing one system, a lot of times these systems are intertangled and they're all dependent on the structure of the vehicle. So until we start really measuring every vehicle that potentially could have a sensor that moved or disrupted, we're not completely indemnifying and bringing that car back to the pre-loss condition. So we want to start off by verifying the structure. This is something that we've kind of done in the industry for a while. We've always been looking at that lower body and making sure the lower body needs to be where it needs to be. And then, of course, making sure that we've got all the access to the data to reference to make sure that, okay, yeah, it's square, but maybe it was hit funny, so it looks like it's square, but it's really not. We need to make sure that we've got easy access to all of that data. And then we also need to realize it's not just the underbody. We need to start actively measuring the upper structure of the vehicle, however you want to do that. You know, right when it comes in for a pre-tear down or after you've disassembled some components off the vehicle. We need to start doing this on the beginning of the repair to confirm that, you know, that upper body damage. If something's hit extraordinarily hard, maybe we start thinking outside the box. Maybe if we think that two rails have just totally mashed in and we can't even trust the strut towers anymore, those might have damage. Well, maybe we need to start working our way up to different parts of the vehicle and different parts of the structure to start finding something that we can trust, so then we can go ahead and find and document the true damage and find exactly how far back it goes. But identifying this damage today isn't as easy as it was, you know, just 5 years ago with all the different high-strength steels that are being released every single year by the manufacturers. The cars absorb energy differently, and so it's a different process to find that damage and see exactly where it went in today's day and age. Our margin of error, unfortunately, has gotten a lot smaller when it comes to these newer vehicles. So Sergio, I want to kind of turn it over to you and bring some of the technical sides into this, and we can start explaining kind of how some of this ADAS works in relation to the structure and the suspension, and then how we might be able to go ahead and start documenting this and putting this on an estimate for a bill payer during the actual repair process. So Sergio, if you want to take over.
Yeah. So like Avery described, you know, a lot of the ADAS is based on a perfect world scenario, you know, the vehicle structure being correct. The other to that is the alignment. One of the first things before doing a calibration is an alignment has to be done to the vehicle. Well, before even being able to do an alignment, a proper alignment on a vehicle, wheel alignment, we need to verify that the structure is correct. So as a shop, once we verify that the structure is correct, we need to verify that the alignment is correct. If not, we will have a vehicle going down the road, potentially dog like what we see here on the screen. Ultimately, having either failed calibrations or improper calibrations. Like Avery mentioned, the margin of error could potentially be feet when we're talking in millimeters. As we can see, you know, depending on the type of sensors that we have, they're reading out 300 feet. 3 millimeters at the vehicle could potentially be 18 feet. You know, we can multiply that, 600 feet, and now we're sitting at 36 feet. So very important that the structure of the vehicle be correct, not only the lower body, but the upper body, and then the alignment. And then we can pinpoint down, where the cameras and sensors are. We can start now being able to measure those locations, being able to do some comparatives of the vehicle, or doing vehicle match comparative, which the Matrix 1 has the ability to do. And we can start measuring things, whether we do it in 2D, point to point, as we can see there, being able to measure through objects, or do a comparative in 3D, as we can see here on a blind spot monitor sensor. There again, we verified the structure of the vehicle, everything is correct. You know, if we replace the quarter panel, we need to verify that it's in the correct placement before we even put a bracket or more so a sensor. And so we can do comparative measurements as we see here and be able to truly measure it in 3D and now be able to have that documentation that we've done and taken all the steps correctly so that we can avoid a lot of that liability. And also, it also gives us a peace of mind so that when we send something out, whether it's for an alignment or calibration, we know it's going to properly calibrate our line and not play that dancing game of sending it out, coming back, and doing a lot of the trial and error. So we're able to document and be able to see that in 3D at various different locations, whether we're measuring the sensor, the bracket, quarter panel, the mounting location, we can be able to now see that visually, and it's very transparent. Anyone looking at this can see that this is the vehicle that we are working on. We can see the area that we are measuring, and then we can see the measurements there highlighted in colors and in millimeters in each of the length, width, and height measurements.
You know, Sergio, just to kind of bounce off what you're saying, you know, that's really important, is the documentation aspect and having a picture of the actual vehicle when it comes to this. A lot of times when we talk to insurance companies and insurance adjusters and they get measurements from a shop, you know, they appreciate that, but in the back of their mind, they're wondering, you know, are these measurements that I can actually trust? Have these been flubbed? So whenever it's possible to capture that in an image and add that image into your documentation, it really increases your chances of getting compensated for taking that measurement tenfold.
Correct. So we can see here other applications being able to do various different measurements. We can see here the area of location. You know, these are vulnerable areas where a lot of these sensors are placed. A lot of times it doesn't take much to move these out of alignment, even though we find no structural damage or even see visual structural damage. With measurements, we can now verify. You know, simple as this one here. This was a Honda Odyssey, had been impacted in this corner here, the driver's side rear bumper cover. Some damage to the bumper cover. The body shop was going to replace the bumper cover because of the damage. Didn't allow any repairs or paint to be done in that area. But the shop was looking at the sensor and everything seemed to be okay looking at it. But they just wanted to verify and now be able to document that way when they send that out for calibrations. If there's any questions they had, verification of that. And this was just a comparative done of the actual sensor itself. You can see on the top, on the right-hand side, they measured the actual bracket of the blind spot monitor sensor there. And we can see that it measured on the measuring points there in the left bottom corner, everything measured within 3 millimeters of length, width, and height. They took it one step further and just unmounted that bracket from the quarter panel and measured the mounting nutserts that the Honda uses. And we can see that at those points, 7, 6, and 8, they all measured within 1 millimeter respectively in 3D. So they were able to verify that there was no movement to that inner panel, and they could now proceed on with the rest of the repairs for this vehicle.
So now, Sergio, when they're ready to take this to the actual calibration process, now we can start verifying that we're setting the calibration process up, you know, per the OEM spec as well. Can you kind of explain that whole process and kind of why that's important?
Yeah, that's important as well, because, you know, we want to verify that we've checked the area correct, you know, where that blind spot monitor sensor is or camera, whatever it may be, to verify that's properly done or measures on the vehicle. One step further in being able to verify and document is the procedure for the calibrations. So I know a lot of shops, more of them are bringing the calibrations in-house. And one of the things I keep on hearing is, well, how can we verify that we did the calibration process properly? Well, using the matrix wand, that's another thing that we can do and verify. You can see here these various different sensors sit out in front of the vehicle. At a certain distance, we can see that on the left hand, that Toyota Camry, that prism sensor is supposed to be set out 3,000 millimeters in front of that vehicle. We can see that that measurement there in the red line shows to be 3,000 millimeters. We can see that also we're checking to see that it was centered. We can see that that point 2 where the orange and green lines go from, we went from the A-pillar points down, and we can see that those measured evenly at 1,887 millimeters. So it's just one more step to be able to verify that during the calibration process, we are doing it correctly. Because unfortunately, I've seen, and I know me and Jason did a video of people falsifying calibrations just to get them to pass. Unfortunately, there's people putting videos like that on YouTube. And this now we can see, cover our butts in the process of doing the calibrations. Same thing here on the right-hand image, that same vehicle, doing a setup of the blind spot monitor sensors. We can see there, we got all the markings lined out on the floor, and we selected those points and measured everything out. And all our measurements are measuring to where these markings are supposed to be. So they're the exact same measurements that the OEM has, and they're using the plumb bob to drop them down. But now we're just measuring those points out on the floor in space with the vehicle in the image and the area where it was getting calibrated at. Same thing here is another one. This one we can see the wheelbase. We're measuring back from point 1 to 2, all the way back to where that target's supposed to be, from the center line points, from the wheelbase area, and be able to have measurements showing that the targets were placed in the correct area and not taken up to a camera and getting it to just calibrate or pass. We can actually verify that we've done the calibration properly.
So Sergio, now that we kind of have the sensors on the car, the ADAS sensors verified that they're where they need to be, we know that the structure is where it needs to be. We've documented all of that during the repair process. Now we need to kind of transition into suspension and making sure that the suspension is, going to be able to take an alignment, making sure there's not any damage. And if there is, really trying to pinpoint that damage. Can we kind of go on that and how it relates to ADAS?
Yes, so pinpointing any potential issue right at the beginning obviously is the most important thing. From my background of being a technician and working with various different shops, pinpointing the issue of why we had a failed alignment is always a guessing game a lot of the times, or we're throwing various different parts. And so with the Matrix 1, we can now pinpoint this there again ahead of the time before this goes out for an alignment. On the screen, what you see here, this is a Honda Accord. This was actually one that I was doing at a shop demonstrating. They pulled this vehicle in that morning. It had impacted, there was an impact to the driver's side wheel that had actually exploded the rim. We could physically see some damage in the inner wheel well there by the dog leg of the fender. And the only visual component that we could see that was damaged was the outer tie rod. Looking at everything else, everything looked to be pretty good. The wheel did kind of look to be a little bit pigeon-toed, towed in a little bit, and then kind of set back. So we potentially thought, okay, maybe some caster or misalignments. So the first thing we did is we measured the knuckle, and we can see that point 1 to 2, we're measuring from a top casting mark on top of the knuckle to the center of the hub assembly, and then to a point on the strut. And we did a comparative from the driver's side to the passenger side. And we can see that our measurements of our knuckle measured dead even at 248 millimeters. We are 2 millimeters deviated there from our strut point to our center of hub assembly or half shaft there, which could show just needed to be aligned. So we wanted to verify that there was no damage on the knuckle itself. So then we measured from the ear portion of that knuckle where the outer tie rod bolts in, and we measured to there again to the center of the half shaft. And when we measured here, we were able to see a deviated measurement of 3 millimeters from one side to the other, showing that in this cast component, there was a 3 millimeter variance. And from the various different components, especially cast components, knuckles, control arms, typically anything over 2 millimeters is damaged and won't be able to get aligned properly. So now we're able to verify that the tie rod was bent due to the hard hit that it took, and we're seeing here that the knuckle itself has some damage in it as well.
But Sergio, on the knuckle itself, there was no physical damage. There was nothing that we could have taken a picture of as an estimator and uploaded on through CCC or Mitchell to get approval to replace that knuckle. It was just it had different specs now because it was damaged.
Correct. Yeah, there was nothing showing that that thing was bent. There was no cracks, no paint flaking. Um, it's just when we did the measurement from these casting seams and marks, we were able to show that. So then we took it underneath. We raised the vehicle up on a 2-post lift. We wanted to verify, obviously, the structure of the vehicle, but also the cradle. Did the cradle get impacted enough to damage it or misalignment from the vehicle? These are a lot of the steps that we take into verifying whether we've got a suspension component that's damaged. Obviously, there again, we want to verify if the structure is correct, which we did on this vehicle. We measured from the torque box areas all the way up to the front core support. And then we squared out and verified that our cradle was not deviated or bent, twisted. There again, everything was measuring out to the specs that we're supposed to have. And then the last is we wanted to verify that the cradle itself wasn't misaligned to the vehicle. And from our measurements that we see here, we can see that we measured out to the cradle from points 1 to 6. We can see there measured out at 1,385. Points 2 to 5, which would be the cross measurement there, 1,384. And then our straight line measurements there, point 1 to 5 were 1,007. And points 2 to 6, 1,005. So we're within a couple millimeters there, and all within the spec data that we had for this vehicle. So from there, then now we wanted to validate to see if there was any damage to the control arm or misalignment. We could see that in the inner wheel well, the wheel had actually impacted in that area. So we wanted to see if we had a potential lower control arm that was damaged. If we take the measurements of 0.2 to 12, we can see there that that was measuring at 595 millimeters. And the opposite side was measuring at 614. We can see there at 501 to 518, points 4 to 12 as well. Those were areas from the torque box area. So we could see that we had about 17 millimeters from the ball joint down to the torque box area deviated from one side to the other. So we could clearly see that that lower control arm was back. Obviously, this was all done in point-to-point, two-dimensional. A lot of things you can do with your tram, but by being able to use the Mitchell reference data, we were able to now compare those in a point-to-point, as you can see here. We were able to take it one step further and take it into a 3D analysis. And so here what we did is once we selected our points, we just compared our points to the Mitchell spec data that is integrated into our system. That way, that's why you can see here on various of the points, there's a letter associated to the number. There's known 3D data for those points. And so we can see that at the points for the cradle and the structure of the body, everything was measuring correctly in the green, as we can see there. Where we see the measurements there in red are on that lower control arm. And we did a comparative on that to the opposite side. And on that measurement, we could see that we were actually back by 23 millimeters and swayed out by 5. So not only did we have a knuckle that was damaged, we had a lower control arm that also had some damage. But we verified that there was no movement to the structure, no movement to the cradle, or any damage to the cradle. And here's the points that we associated when we did a 3D data to the Mitchell specs. It actually provides an image of various different points. Now on that lower control arm, we did a comparative because they don't provide any 3D data for lower control arms, ball joints, knuckles, and such components like that. But as far as the structure, we can do that.
So Sergio, now that we've kind of gone through, we've verified the ADAS positioning by verifying the structure of the car. We've gone through, we've verified, the suspension damage and where we're going to see that suspension damage. Now it's a matter of documenting all of our findings and needed repairs for the bill pair, and documenting it in a way where we can really feel comfortable that we can guarantee that we're going to get compensated and get everything we're asking for. So when it comes to getting compensated by the bill pair for these repairs, and when it comes to ADAS and structural and suspension damages, we need to make sure that we're meeting the contractual language of the policy. That's super important. there's certain things in an insurance policy that you need to be that specifies that that's the vehicle insured. And the more that we can include that language and that information into your documentation, the better of a chance you have to get compensated for that repair. Because no matter what, we're all good collision repair professionals. We know we're going to do what's right for the car. It's going to leave right, for the OEM procedures. Now we just need to make sure that we have the easiest time getting paid for it. So the things we need to look for: the year, make, model, and VIN. If we can make sure that we can verify that that's the vehicle that we're talking about in the pictures, we're going to have such an easier time. So when it comes to your report that you're submitting in with your estimate, when it comes to your damages, we need to make sure that that language matches the insurance contractual requirements. So we've got the owner's name of the vehicle, whoever the insurance policy is under, the year, the make, the model, and the VIN. It needs to be clearly identifiable on any documentation that you're submitting. We also need to make sure that we're including any of the supporting reference data that we use to come to these findings. So if we're using the Mitchell reference data to find our trusted triangle or to trust certain parts of the structure, we need to make sure we're including that, and it's easy to find in all of our evidence. We also need to make sure we're including all of the images of the vehicle, the actual images of the vehicle. The CAD drawings are great, but like we were talking about earlier, the insurance adjusters, in the back of their mind, they're not sure if they can trust that. Let's use an image of the actual vehicle to prove that that's the vehicle that we're repairing. There's no way that we could have flubbed these measurements. And then we need to also include that 3D supporting data, whatever our findings actually were, that support what we're asking for on our estimate. So kind of in a quick review of everything we've covered so far, we need to verify the structure to start with, and we need to document that process. We need to go ahead and verify that our ADAS mounting and sensor locations are correct, and then we need to document that process as well. And then finally, we need to verify that the suspension has a great alignment before we send out for recalibration, and document that process as well. So the tool that we use to do all of this today, to kind of show you these examples on how you can document effectively when it comes to the structure and suspension, we use the Matrix Wand. If you're not familiar with it, it's a 3D measuring tool. It uses photogrammetry, what we call stereoscopic imaging, to find all these measurements. We recently just went through and kind of revitalized a lot that goes wrong with the wand. So it's got a fresh new paint code that we're putting on the wand. It used to be gray, it's now red. We just updated the cart here recently as well. And as of last week, we have a new pricing structure as well. So if you're interested to learn more about the wand, please feel free, reach out to us. We'd love to schedule a web demo during these quarantine days. It's very software based, so we can kind of jump on there and show you live examples through the software and through the actual images of the vehicle. Another cool thing that we just launched that Kristen kind of was alluding to at the beginning of the webinar, if you happen to get on a few minutes early, was our online training. So we just launched Fenderbolt, which is the new version of our software that powers all the Matrix repair analysis software. On Fenderbolt is our online training. So we've taken our same on-site training experience, put it into modules, and put it on the cloud. So now all of our users out in the shops can easily access training. If they get someone new in the shop, they can easily get them trained up pretty quickly. One thing that we've decided to do during these times when we have to stay at home is offer this training to you. Even if you don't have a wand, we're going to go ahead and offer it to everyone in the collision industry. They can go ahead, train on the wand, how you use the wand, how it can benefit your shop. And it's good for 1 iCar credit hour. So by using that promo code that you see there on the screen, MTX2020, you guys can go to fenderbolt.com, throw in your iCar ID when you're registering in the field and your name and number. You can go ahead, complete that training, go ahead, get your free hour of iCar credit on there, and try to make some productive times of these uncertain times. And then I also wanted to go ahead and let you guys know we will be doing another webinar with Kristen here on the 17th. We're going to be partnering up with Roger Cada from Accountable Estimating, and we're going to be diving into diagnosing and documenting structural repairability, kind of going over all those high strength steels, talking about megapascals, side body damage, identifying that inner structure damage, and trying to find those total losses earlier in your repair process. So with that being said, I really want to thank everyone for joining us today, and I want to thank Kristen for having us. And I guess I'll go ahead and turn it back over to you, Kristen.
Yeah, great. So I'm going to jump back and change gallery view, get everything back on. So I'm just going to check the chat room, see if there's any questions that come up, or if anybody who is logged on wants to ask any questions. We use the Matrix Wand in the studio. We also take that Matrix Wand with us. It's so portable. I can just put it in the box and take it with me wherever I go. It does look like a gun case, so I get weird looks when I start pulling it out of the car. But it is a extremely versatile measurement tool. So we recently, and we talked about it on the last webinar as well, we had Jake Rodenruth and Aztec join us, and they have, I believe it's 5 calibration centers across the United States, and they do nothing but calibrate after collision centers have finished the repairs. Now, it's pretty good to say that if a shop is forward thinking enough that they're letting Aztec do their calibrations, that they're probably one of the higher performing, or they are the higher performing shops throughout the country. And 40% of those cars that are coming in to be calibrated have a structural issue. And I think in our industry, we confuse structural with, we think frame rail. So we're thinking, what, these cars have frame damage. And that's not necessarily the case. It's you didn't position the wheelhouse correctly before you put the quarter panel on. And so when you welded the quarter panel in, it's now off. And then now how you mount the brackets for the sensors are off. And so lots to do there, and lots of measurements that could have been with a really simple measuring tool. As a shop, you can run those down. And we're forgetting. And I think OEs are getting a little better now about giving us those position measurements where we didn't used to have them. We'd get under dimensions from OEs, but we never got a here's where the sensor goes until recently. So lots there. Anybody with any questions?
Yeah, I have questions.
All right, there's my man. Where's the dog? Dean, where's the dog?
She just went outside. Instead of getting her to pee on the floor, we're going to try to teach her to pee outside for a change. I missed the first 10, 15 minutes. I apologize about that. But my questions and I kind of caught at the end, it looks like you have some pre-stored data where you guys are measuring things out. I mean, I've kind of been interested in this tool for a while, but I don't know a lot about it yet. But is it like for the sensors, what you were just showing, it's doing comparisons, and you were doing that on the suspension as well. So and my question is basically, if you have damage on both sides, what are you doing in that situation? Or like, in the front of a vehicle where you have an active cruise control module in the front of a Volkswagen where there's only one module, what's telling me that that's in the right place? Those are my 2 main questions. And then, I guess as salespeople, I don't know if you'd be able to tell me what are your weak points, but I'd be curious to know if you have any weak points.
Hey, Sergio, this is kind of geared towards you. You want to take that question?
Yeah. So with the Matrix Wand, obviously data is the most important key. And like Kristen said, OEMs are getting better, giving us some positions, and measurements of certain areas, but they're still lacking a lot that we need to know as repairers. So one of the things that we can do is that the Matrix Wand, if there is no data, brand new vehicle or a vehicle you never worked on, and there's no OEM data or even Mitchell reference data for that matter, we can make our own. Now, if you have a vehicle that, let's say, both suspension control arms are damaged or both blind spot monitor areas are damaged, in that case, we would have to probably do a vehicle match comparative. Being that the Matrix Wand is handheld and portable, it can be easily done. So if you have to go get that, or you have another car in the shop, we can find that very easily. The other thing is the Matrix Wand you store that data. At this point, every system is self-contained, but the first launch of our Fender Bolt was getting to that cloud connected. In the future, we are looking to be able to do sharing of data. So that way, if any other Matrix Wand users potentially have the data that you need, that will be available. That's still something that's in the works at this moment. I don't know an exact date of when that would be released, but at this point, it would just be being able to do a comparative opposite side vehicle match comparative.
Yeah. So I'll expand on that. And the way we use it is that, for instance, your Volkswagen example, if Volkswagen doesn't have a position for that sensor, no measuring system is going to have a position for that sensor. It doesn't matter who has it. So in that case, the beauty of it is I can go find another one and do the comparative through the photo geometry stuff that allows me to do things specifically on newer cars, the 2020s, and now we're getting close to the 2021s, that I couldn't do with my old measuring systems. So I used to go put the VIN in, load it up on the car aligner, and I'd go, oh shit, no one's measured this one yet. And if the OEM hadn't given me dimensions, I was sometimes going back, hoping same body style, hoping whatever. And so the Matrix One does that really well in that respect. And then it does use now pulling in all like the Mitchell data, which is coming usually mostly from Chief. So it has those numbers for comparisons when you're doing the underbody measurements, which is really nice because it's quick, point to point. The other thing that it does for me that I can't get my other measurement systems to do, so is one of the things that we demoed, or he had a picture of here. And Avery, I don't know if you can go back and show it.
Sure.
But it allows me when I'm doing calibrations to really know where the targets are in a way that I've never been able to document before. So if you were on the call, Jason, was that yesterday? The days are running together. Yesterday with Opus, and we're talking about from their perspective as the third party scanning the vehicle, they have to ensure the technician has actually followed these rules, that they've done the measurements right, that they've done the center line, that the target's in the right place, it's the right distance, it's the right everything that's supposed to be. So as a third party scan tool company, they're trusting that all that was done, because literally the Matrix One will measure anything, like the door frames in my office or or where the trees are in my front yard. Just because it's science, I can do something like this photo and I can visually prove beyond a shadow of a doubt that I had everything right where it was supposed to be. And that photo documentation is amazing for me. The other thing that's really cool, and they don't mention it about this tool that I talk about all the time, that I would love from a court perspective, is your measurements are evergreen. So meaning you measure this car here with this picture, I could go back a year later, choose new points and take new measurements. Sergio usually always tells me if you can see it, you can measure it in the photo. So if I was preparing in a court case and my shop had forgot to measure some measurement that, I really wanted, or Larry, when it comes to suspension, oh my God, the things he wants to know, I could pull that up really quick and remeasure, and I don't have to have a car ever again in my shop, because once I've got those photos in, I'm measuring that car for life. And that's something I can't do on any other measuring system either. So one of the things that I do love, it's extremely versatile. So hopefully, I don't know if you guys will eventually share with the new, I don't even know, brand new announcement on a new pricing plan. I was like, really? What's the new pricing plan?
It's exciting. So we've kind of given the shop a little bit a few more options when it comes to how they're building their wand and how they want to train. So it's pretty exciting stuff. We were just had a conference call on it yesterday to introduce it to us. So we should be making some announcements here. Stay tuned. You should see something here on all the collision sites in the next 7 days or so.
Awesome. I'll say, I know that they're going to probably cover it later. I've used this to, I'm going to get in trouble. So this is the opinion of Kristen at Collision Hub. It is not the opinion of the Matrix Wand or anyone that works for the Matrix Wand. I want to make that clear. I have used this to ship back lots of used parts that insurance companies have tried to ship me. I can measure the parts and very quickly, before they can even kind of unload it off the truck, show why that part is damaged. I've used it to show why, for the longest time with lift gates, we were having lift gate fitment issues, even on the new OE, and I can use that to measure new parts and know whether it's going to fit or not before I go through the hassle of even trying to hang it, which has been nice. We've had issues.
Well, then, Kristen, Chris, and kind of go off of what you're saying on that, you know, with a liftgate, for example, you've got the ability to we kind of touched on that, store that data in the system in your reference library. So as soon as you've got a known good one, you just store it in there. So you're not taking 2 pictures every time. You already have that data in there. So if it was that Volkswagen, like we're talking about, with that single camera, you only have to go find that Volkswagen once, and then you've got that known image saved in there. So the next time you get that Volkswagen in there, it's quick. You just take your new picture of the new one, and you've got the reference data already loaded into the system.
Yeah, I remember it was probably about 4 or 5 years ago. I was walking through a shop in Oklahoma, and the technicians over there doing this and shimmying and you know, going, oh, you have to do this to make a door fit. And we walked over there and took one picture and went, no, B-pillar's off. And it was like, oh yeah. But I mean, I found so many uses for the tools, but right now one of the major ones for me is I can quickly blueprint with it very quickly with low skill. I don't have to have a frame tech or someone trained on my full frame measurement system for my blueprinting purposes. The pictures, insurers really like this system because it's a picture. It's not like you hand somebody a frame report and it's like trying to read an alignment report. And if you've not been trained on it, you kind of don't know what you're looking at. It's just numbers. So that works out really well. And with like 3 or 4 pictures, I can have the frame and the suspension and everything kind of measured, and I'm on my way. So, and that's critical these days. We're going to be posting up pretty soon. We got a post repair inspection. We had a conference call on this morning, and the shop is going to get, I don't want to say stuck with it, but the shop is going to get blamed for what I truly believe probably isn't all from this shop's repair, but because the shop did not pre-measure and even measure it during the repair process, all of this frame damage on this car is going to come back to them. And it was a brand new car. So it's only about 20,000 miles on this car, but something happened to it. So pre-measuring is going to become more and more important. Awesome. Chat room's dead. Jason, did you kick everybody out of the chat room?
It wasn't me.
Hey, on a brighter note, your camera's not lagging anymore. I don't know what you did, but you fixed it.
I don't know what to tell you. I'm sure it'll be messed up again tomorrow.
All right. Well, awesome. Well, Sergio and Avery, thank you for joining us. Thanks for the photos. I hadn't even thought about asking y'all to put those in there, and y'all read my mind and dropped the calibration photos in already. And then we'll see you back with Roger.
Yeah, on the 17th at 2 p.m. We'll be talking about structural repairability and identifying those total losses as quick as possible. So thanks everyone for your time and for having us.
All right. Well, I will encourage everybody not to miss that session. Roger Cato is one of my favorite people on the planet. We worked together for a very long time. In fact, he was a mentor. He taught me a whole lot about estimating when I was very young and dumb. So never miss a chance to hear Roger talk. It's always fantastic. So we will be back tomorrow. It is another jam-packed day. We're going to start the morning with BASF, and we're going to talk about positioning yourself for sustainability. So for some of us, a little late for this conversation, but none of us ever imagined something like that. But John Shoemaker is going to talk to us about kind of some sustainability thoughts as we go forward. And then a little bit later in the afternoon, RSG, which is Refinish Solutions Group. You know Lord Fuser, you guys know Norton, but it's a selection of companies that roll up under RSG. They will be back in the afternoon to talk about materials management systems, and then how that works for estimating. So for some of you, you're spending $400 and $600 in body materials, but you're not estimating that. And we're going to talk about how to capture that tomorrow. All right. Thanks, everybody. Have a fantastic